where we are right now is we came out of the compressor, we're into the discharge pipe, okay? So in this part of our refrigeration cycle, we're, what state? Coming out of the compressor. What's our gas?
Superheated gas.
Superheated discharge gas.
Superheated discharge gas. So that means we are vapor, no liquid, we're above saturation, and we've added heat to that refrigerant, right? Superheated. Make sense? Above saturation. So this is what it looks like on our parallel rack system. Obviously, every single compressor is piped together. There is a large header, we call it a header, where all of our compressors feed into, so that is a common pressure. They all have the same pressure. One's running a little higher, one's running a little lower. They'll average inside the manifold, right? So we talked about our flow control on our compressor, and it's getting oil, right? Well, this is the entire oil system. If we look at the discharge, that's the red pipe. The first thing it's going to hit is our oil separator. So we're going to run through the oil system, how that's going to work, how we're going to get that oil into that oil control, and then several things that can go wrong, really, because that's for text, right? If it worked, we don't care. It's when it doesn't work that we want to talk about. Okay, so that's a picture of my oil separator, right? That's one version of our oil separator. That Temprite, right, yeah, we know that one.
Sure.
That one, if you notice, is kind of sitting out of the way. That's a retrofit. That's not the original oil separator. Didn't fit in the space where the old one did. This is something Kalos is doing, right? We do these on projects. Here's the oil reservoir. That's where the oil goes. It comes out of my separator. And there's my OCV. All right. So hopefully by now, everyone in here has heard something about this. This isn't the first time we've had some type of oil class. Not going to spend a ton of time on it, but I do want to go through it again to make sure that you guys are clear on it. And if you've got questions about any of these pieces and parts, let us know. So the first thing, let's talk about that oil separator. Yeah, let's go through that real quick. So we cut this one apart. We've had it in here a few times. I actually took it apart this morning unintentionally. I'm just going to pass that around. So the oil separator is going to, my hot gas is going to come into this guy, and it's going to take that oil, a huge portion of the oil that's coming out of my compressor, and pull it out of the refrigerant, right? Now, I said a huge portion. How much? Well, it depends on the type of oil separator, it depends on the system, but not 100% ever. All right, we're never gonna separate 100% of our oil. So we're gonna circulate some of our oil through the entire refrigeration cycle, just like a self-contained or a single condenser, single evaporator type system, right? Your air conditioner has got oil in it, and it's going all the way through. Well, we're gonna still do that. Right? We've got to do that because we've got valves in our system. We've got TXVs, we've got solenoids, we've got EPRs. We have all kinds of metal valves, metal on metal. So we want to be sure that we lubricate that. Okay? So we actually have two oil systems. That's the passive oil system that I'm talking about, the one where where I'm not separating from this separator and I'm sending it out to the store. Now, why does that matter? Well, there's a couple reasons. For my startup guys, this is piping, right? It's a passive system once it's installed. But if it's not installed properly, it's not going to return my oil properly, all right? So my startup guys have got to be looking at this to make sure the installers put it in correct, all right? And there's a lot to that, and this isn't really a class about that, but I am talking about traps, right? I'm talking about inverted traps at the top. I'm talking about my risers being one size smaller, or whatever the engineering is calling for, on the horizontal suction lines sloping towards the rack, right? All those pieces have to be right because I am sending some oil through that system. Some of our systems we're sending a lot of oil through that system. So this Temprite we're showing up here, about 98% efficient when the filter's not stopped up, all right? Very efficient, so about 2% of my oil is going through the system that way, all right? This helical that I just passed around, all that it's doing is spinning that oil, and then it's sticking to that screen. That's what I've got, you know, you see, it's not passing through the screen. You guys notice that, that's why I pass it around. You think about it, well, I got a stopped up screen. My oil's not going through the screen. It's running by the screen, and the oil's sticking to the pockets. Then the little droplets connect, and they get big enough that they fall, right? They fall down to the bottom. And the float that we had last week, inside of our float control, right? We've got the exact same thing going on. This is the piece that bolts here. When I build up enough oil, I just lift that up, and my oil comes out, right? That guy works on velocity, right? Speed of that refrigerant, which means under heavy load, when all my compressors are running, it's really hot outside, this guy works really well. 70% efficient, right? So 30% of my oil, in best case circumstances, is going through my store, right? And that's a lot, right? So that means that piping I'm talking about, critical. Okay? That's best case scenario for this guy, right? January, middle of the night, staged off 3 of my compressors, right? All my cases are at 10. Yeah, this guy could be 30% efficient, maybe even 20, right? So the majority of my oil in that scenario is going through the store, okay? So when we're diagnosing oil problems, it's really important to remember we have these two systems, okay? The first thing is we got to know whether this system is working or not. It may not be working at all. If this stops separating, 100% of my oil is on that other system, right? Does that make sense? So if that's what's going on, I got to be able to diagnose that. I got to be able to figure that out and then understand what's going on with my system and why it's not functional, right? One of the tells that I've got a problem with one of the two systems, and I'm trying to figure out which, right? Is this a piping problem, or is this a problem with my active oil system? Right? One of the tells is change in weather. Do I have an oil problem that begins when I have a significant change in weather? Do I have an oil problem that magically solves itself when I have a significant change in weather, right? Weather should not impact our oil systems. Right? If it does, that means I'm shifting my load from one oil system to the other. The problem, for instance, let's say it gets cool, right? And I've got one of these, and I start having major oil problems. Well, we know we've shifted the majority of our load to the passive oil system. I got a piping problem, right? Okay, and vice versa. I got oil problems, and then spring hits, starts warming up, magically fixes itself. This guy's now separating way more oil, right? I've taken that load off of that passive system. Does that make sense? No. Right? If this guy isn't separating at all, there's a couple phenomenons that I'll typically see. One, my reservoir's gonna run out of oil, my tech's gonna be adding oil. Right? He's gonna have compressors locking out, my reservoir's dry, he's constantly adding oil, you know, once a week, once every 3 days. He's putting a quart of oil in this thing, right? One of the first things we gotta remember about oil, right? I don't care how old your rack is, it's not burning oil, guys. Right? It ain't no 57 Chevy with blue exhaust, right? If you're putting oil into your rack, if you have to add a gallon of oil and you don't know where the old oil went, you are loaning that rack a gallon of oil. You're gonna take it back out. Right? It's not supposed to be there. This is an emergency. You're putting the oil in literally just to save product while you figure out how to get that gallon back. Okay? Because it's going somewhere. Right? And it's going to come back. The question is, are you gonna find it? Or is the next guy? Somebody's gonna find it.
Okay.
You think it's gonna be you? All right? So just keep that in mind. When you walk into a rack house, Now, there may be a few, because we're working startup, we're doing projects too, right? We're in that strange place where sometimes we walk into a store, nobody's accurately fixed anything in years. Sometimes we walk into a store that we just installed a bunch of stuff, changed things, right? So on the startup side, what we want to do is know what the oil level is before the project starts. Right? If the reservoir is empty when we walk into the store, okay, we need to note that. That may be okay, right? But we need to know that it's not floating a ball before we even start. There may be a pre-existing problem. It may be okay. All right, we're looking for oil cans. Techs tend to leave oil cans, not because, sometimes because they're lazy, but most of the time, that's their signal. I've added a gallon of oil. If you come in behind me, don't think, well, it's been 20 years, maybe it needs a quart. No, it's been 3 days. There's a can sitting right there. Right? Something's going on. Okay? That's one of those signals, we leave for each other. So when you're starting a project, you want to find those cans. You want to see if they're there. Are they having an active oil problem, right? If we're addressing that, if we're changing it, we're going with this temp right, expect to get some oil back. Right? You're probably going to be draining oil for a while. You count how many cans are there, probably multiply that times 2 or 3, that's how many they threw away. So just be aware of that. If we're doing any kind of work on an oil separator, it's very possible one of those racks you're going to hit, the old separator was not functional, okay? If that's the case, somebody's been adding oil, trying to keep things running and they hadn't solved it. Or they have, and they've been waiting on you. All right, one of those two. As a service tech, when I'm walking into these stores, I am looking at that float level the same way. I want to know, what is it doing? Because I need to know, is this a new problem or is this an ongoing issue, okay? Because we don't own the building, that's the difference, right? We're there on a service call. Well, we're gonna be on the hook for 30 days for this, or, for our repair, right? Well, if we got oil problems and we're just walking in, we're not really digging into what's going on, we're gonna be coming back for free, most likely, right? It's gonna be warranted. Okay, so we've got to dig through that stuff. We've got to know that well. Oil problems are probably the most complex thing that we have because there can be so many variables, that play into it.
They are the most complex thing we have.
Yeah. So just the first thing is differentiating between those two oil systems, right? Being able to walk into my rack house and knowing that I've got a functional passive oil system and a functional active oil system is important. So let's talk about how we're going to do that, all right? So the first thing is, and like I said, I hope most of this is a refresher. If it's not, stop me and I'll dig deeper. Otherwise, I'm going to move through this very quickly, okay? So I've got high pressure, superheated refrigerant coming into this guy. It's going to swirl around. My oil's going to run out. I'm going to discharge high pressure superheated oil. What happens if we don't have enough superheat on our discharge?
Condense.
We condense, and this is where it's going to happen, right? Because I'm going from high pressure into this large environment. I'm going to have some kind of pressure drop here, maybe just 1 or 2 pounds, right? On that temp right, with a fresh cartridge, 1 or 2 pounds. I can get up to 10, 15. When it starts getting to that pressure drop, what's that going to do? Instant liquid refrigerant if I have no superheat, right? And remember, our discharge is vapor superheated above SST. Well, if that superheat goes away and it's not superheated, it's at saturation. It's going to condense, right? Not all of it, but some. If I remove 1 degree from that, it's all going to condense.
Then all your oil becomes foam.
Right? Okay, so we've seen this. We've seen this play out. So just know that this is where it's going to occur, right? Because of that change in pressure and the change in the velocity. Okay? When it starts to happen, I'll see it here first. My separator will be cold, okay, or cool, right? While my discharge is supposed to be hot, it won't be. I'll be able to hold it. That's warning bells should be going off when that happens, right? So I got my high pressure refrigerant is pushing on my float. My float is normally closed. It spends most of its life at rest, filling up very slowly, right? Most of the time, it's not doing anything. It's not passing in your refrigerant. When I finally lift this ball enough that it opens, it's gonna shoot out really fast. All right? I'm gonna go from high pressure, I'm always, my entire oil system, high pressure to low pressure. There is no pump. There is no pump moving oil through my rack. There isn't. Not one pump. Gravity is not doing it. The only way that I'm moving oil from one place to another on my rack system is via pressure. High pressure to low pressure. So when I'm troubleshooting this, there are two tools I'm going to use. Temperature, to tell me what's going on as far as flow, and pressure. Am I moving? Do I have the proper pressure at the proper place? All right, if I don't, back up one step. There's my problem. All right, what's not creating that pressure differential? Must have a pressure differential, high pressure to low pressure. Okay, you said, well, but I got an oil pump in my compressor. It's internal, right? It sucks in the oil in the compressor and discharges it in the compressor. That's not moving oil anywhere other than inside that compressor itself. Has nothing to do with my oil system.
Right.
All right, so we know this is at high pressure. If this ball opens and it shoots oil out really fast, it's got to be going to a lower pressure. Has to be, right? Okay. So what is our lower pressure? Our lower pressure is our oil reservoir. All right. So, and it's usually mounted over the top too, right? You know, so there is no mistaking gravity on this guy. All right, we got flow uphill. You know, we're coming out of here. We're going up to my reservoir. All right. So how is my oil reservoir going to be at a lower pressure than discharge? Has to be, right?
OCV?
There's my OCV valve, right? That's why I'm going to use the OCV. OCV, oil check valve. That's what OCV stands for. It's a special valve that Sportland makes for this sole purpose.
Never put two and two.
Right? It's going to have a dash and a set of numbers, 5 to 30. Okay? The numbers are the pounds. Okay? We'll talk about that. Traditionally, 20 pounds is what rack engineers call for. Now, you're going to see a lot of different things. You'll see 5, you'll see 30. Right? But 20 is what the rack manufacturer is going to call for. Now, I say that, I'm sure there's some rack manufacturer somewhere that's calling for something different. But that's Hill Phoenix, that's Kaiser Warren, that's Zero Zone, that's Hussman, that's the big ones, all right? Obviously not Carnot, they're CO2. They're using an electronic valve to control theirs. But anyway, it's the same idea, right? So the idea is, the concept is, wherever that OCV goes, all right, I'm gonna bleed all that discharge pressure out of my reservoir down to wherever that pipe goes plus its number. All right, so normally that's gonna go to suction on a regular rack, conventional rack, that's gonna go to the suction. If it's a 20-pound check, that means I'm gonna bleed that reservoir down to suction pressure plus 20 pounds. 20 over suction, right? Is that less than discharge?
Yes.
Yeah, so that's why I'm gonna move my oil very quickly, right? It's a big difference. It's a big pressure difference. So the higher the pressure difference, the faster my oil is gonna travel, right? So it's gonna move through there very quickly. Now, I've got a sight glass on that oil line. Most of them are black and you can't see anything through them, but at one time,
It was clear.
it was clear. If we're doing a conversion there, you know, changing these separators, probably changing the glass. All right, so what am I looking for, right? Why do they give us a glass to see things? I don't know. If you catch it actually feeding, you'll see oil shooting by that glass very fast. But I just told you, it spends most of its life at rest. So what are you probably going to see? When you walk up to it, you're probably going to see what looks like solid calm, right? And little tiny bubbles drifting by. Oil's not bubbles. What's that about?
Discharge gas.
We got a little refrigerant mixed in with that oil.
It's not a purpose.
Right? I just told you, this separation process is not complicated.
Yeah.
Right? We're going to have some refrigerant mixed in with that oil. All right? So what you're seeing is the ball's closed. The ball is trapped, that oil. My OCV has vented itself off. It's closed now. My refrigerant, my oil's not moving. It's all sitting. And that refrigerant is slowly boiling out of that line. So it's gonna rise, and we're gonna watch those bubbles go by as the oil between here and that sight glass, as the refrigerant starts to slowly separate from the oil, right? It's gonna start just bubbling by. That's what you see, okay? All right, what should you feel? I told you temperature, right? That fill line will tell me a great deal about what's going on with the oil system in my store. If I walk up to that fill line and I grab it, I'm gonna feel one of three things, right? It's gonna be hot. If that is hot, like discharge hot, that means this ball is open all the time. And it is discharge flowing through here, right through my ball, right up to my reservoir, and out the OCV continuously. That's what's happening, right? That should not happen. That's a problem. Hot pipe means I've got some crap or something holding my ball up. My ball can't seat. The pin cannot close inside the hole, right? There's something preventing it from doing that. I'm not gonna separate if that's going on, guys, right? So if that's going on, I'm gonna be out of oil, my compressor's gonna be locking out, that's probably why I'm here, right? And my pipe is hot. If I touch my reservoir, it's probably also hot. If I touch my OCV, it's gonna have some heat on it. Right? That pipe coming off my OCV. All those things will be warm. But I'm going to where that sight glass is, and that's the pipe I'm gonna grab. It's gonna tell me that right away. Right? Second scenario, I walk up, it's room temperature, or even cooler. All right? It feels like the metal on a rack the compressor sit on. You know, touch that, I touch that pipe, same thing. What's that tell me?
Dryer or closed.
Tells me this ball is never opening. I'm never feeding oil out of my separator into my reservoir. That's why it's the same temperature. It's nothing moving. It's the same temperature as everything else in the rack house, including the walls, right? They're all in ambient, okay? All right, so that tells me, yeah, he mentioned the filter, right? That ball is never opening. This thing is nasty, dirty, or I've got a restriction in that line. Well, I do have an oil filter that comes out of here before that sight glass. It is potential 100% stop, right? It'd have to be. And the third scenario is it's warmer than that, but not as hot as my discharge, somewhere in between, right? What temperature at? Totally depends on how often it's opening. Totally depends on how fast my compressors are pumping out oil. Totally depends on how efficient my separator is at separating. Right? So I can't give you that answer. The more it opens, the warmer it's going to be. Right? We did a class not too long ago. When I walked in, it was almost room temperature, just slightly warmer. And while I was talking, it got warm. Right? I could feel it open. Probably 20, 30 minutes in between ball openings on that guy. Right? Wasn't moving much oil. 20, 30 minutes is a long time to not feed oil. Is that normal? Yeah, absolutely it is. Right? Sometimes longer.
Would that be related to the refrigerant that we were using, since 449 isn't really all that great?
So it shouldn't matter, but does it change it? Yes.
Yeah.
Right? Is it okay? Yes. Is it going to be different than it was when it was running 22 in mineral oil? Definitely.
Like what? I lost.
So change the refrigerant type. We're also going from mineral to POE.
Yeah.
Right? So we change those two refrigerant. We do a conversion. Right? And we walked in before the conversion, and this guy was feeding every 15 minutes. We finished the conversion, and now it's feeding every 30. Is that okay? Or vice versa?
As long as we're not running.
Well, I mean, POE is a detergent, so it's gonna clog the flow, right?
It's going to flow differently, is my point.
Okay.
Right? We're going to get different flow rates. We're returning different amounts of oil from the store than we were before. Right?
Velocity change.
So
The
that-
velocity is definitely going to be different. The viscosity of the oil is actually different. Right? We think of it all being 130 or 150, but it's not.
So what would that, is it typically, is POE typically like faster or slower or what? I don't know.
And that's my point. It's just different.
Okay, it's just different.
All right? So expect a different flow rate,
We
right?
were just
And
saying
each system is gonna be different in each system. You'll have one compressor that wasn't passing too much oil when it had mineral oil, but with POE now, it's cranking out a gallon an hour, right? It just all of a sudden started cranking out a lot more oil. because it's just flowing differently through it, right? Then you had another compressor that was pumping out a gallon an hour that now isn't, right? Everything just changes a little bit with our temperatures are all different. The size of the molecules of the refrigerant are different. The oil is definitely different, right? The timers, we talked about this last week, that are oil pressure safeties, right? For POEs, 120 seconds. For mineral oil, it's 45. If there was no difference, you think there'd be a difference in those? That's pretty dramatic. That's a huge difference. Okay? So anyway, that's my point, anyway. So as a service tech, when I'm checking on my oil system, that's the first thing I'm gonna do is grab that pipe. It's gonna tell me one of those three things, right? Okay? And I'm gonna use that information to start diagnosing other things. All right, how many balls should we be floating in an oil reservoir? Anybody know?
1 or 2.
All right, so the idea is 1, okay? But let's talk about it in practice, the way this plays out. So that one I got a picture up there, has 3 balls. A lot of them only have 2, right? They're a third smaller. Okay, hold a couple gallons, that's it. All right, how much oil do I need for that separator to work properly? About a teaspoon, right? I just got to cover the hole in the bottom so refrigerant doesn't blow out into my compressors, right? The bottom coming out of that is going to my oil float, right? My oil control, mounted on my compressor. So I got to keep that hot gas from pushing out to my oil control. So I got to have a full line of oil. That's literally all. I don't need any more than that. So what's the story with all these balls? Why do I need one? Why do I need 1 ball floating? Right? Because I don't know if I have 0 teaspoons of oil in there and I am blowing hot gas, or if I've got enough oil in there that I'm not. I have no way to know that between 0 and under the first ball. I have no way to know. So the first ball is for me to know I have enough oil. That's why I have 1 ball. That's why we say we want 1 ball. If I walk into an existing system that does not have 1 ball floating, am I looking at that going, that's a problem, I need to add a gallon of oil? Maybe not, depends on what's going on, right? Probably not. Now, startup techs, if your spec is float a ball, add the oil, right? But you're doing that as part of the project, not because you don't know where the oil went and you're trying to put a gallon in there because it's not gonna work if you don't, right? You're only doing that because that's the spec. If that's not in the spec and it's sitting there dry, leave it dry. Okay? Right? Oil problems can also be long-term problems. That tech may know exactly what's going on there. He's waiting for winter to get all his oil back out of that walk-in fridge. I'm gonna check that pipe and I'm gonna look for that glass, right? I wanna see 1 ball floating. If there's not, and I'm not having any oil problems, I don't care. If I am having oil problems, I may be bringing it to 1 ball floating so I can monitor it. I'm adding a gallon, not because remember I said I'm borrowing my gallon, right? But I can't be sure I have enough oil to make it through the night if I don't see 1 ball floating, right? So I may raise it to 1 ball, and if that disappears, I know for sure my system is running a negative amount of oil, right? It's all going somewhere. It's just a matter of time until my compressors lock out again, right? Okay, so I may do that 1 time just for that purpose, but I'm gonna note that. I'm gonna make sure, I'm gonna leave the empty, right? I may put a tag on it, I'm gonna write in the logbook. I know you guys hate writing in the logbook, nobody likes writing in the logbook. Great place to leave notes to each other. That's one of the situations where it's really important that I do that. I may not be the next guy that comes back, right? And the next guy who comes back is gonna do the same thing. He's now got 2 gallons that we've loaned this rack, right? And then 3, okay? So I'm gonna make some notation there. That's the only time I would float a ball on purpose, is if the spec called for it and I'm a startup guy, right? And I have to do that as part of the project, or I am actively troubleshooting oil problems and I'm getting a reference. I wanna see this ball float and I wanna see it go up, not down, right? Okay? So how about my top ball? What's that about?
You don't wanna see that.
Okay, so if I hit that top ball, am I in trouble?
Yes.
You're
Potentially.
Yeah.
Almost.
OCV.
Technically, I'm not. It's the same as the teaspoon, right?
Oh,
Yeah, I'm not really in trouble at that point,
yeah.
but I am in trouble when I hit my OCV valve. When I fill the entire thing with oil, my OCV valve can only regulate vapor, not liquid. Right? When that happens, my differential pressure is gonna go to 0 for my suction. I'm gonna stop flowing oil, right? After I just filled way too much. Right? So I cannot hit my OCV. Well, I have no way to know if the oil level is right over the top of the top ball, or if it's at the OCV. I don't know which. So the top ball is my last indicator as a technician. When I see the top ball floating, it's a no shit. I don't know how much over that level I am. Right? So that's why we say we never want to see the top ball floating. Technically, I'm okay if it's just barely over, but I have no way to know that. I have no way to know.
Traffic light, top is red, no go,
No go.
stop.
No go. Okay. So, let's run through our pressures real quick. Discharge pressure. My reservoir, do I have I still got my little red highlighter, check it out. All right. My reservoir is sitting at suction plus 20 at the most. Is that what I'm gonna find every time?
No.
No.
No, I'm gonna find less than that.
Yep.
Right? Unless I just catch it right as this ball is feeding.
And you're getting.
When this ball is actively feeding, I'm bleeding off 20 pounds over suction. When this ball closes, I stop feeding discharge into my reservoir.
Yep.
It can only go down from there.
Yep.
Yep, it's going to low pressure.
All right? If my suction pressure changes, if it goes down, my OCV is going to bleed off oil pressure to keep that 20. It won't let it be 25.
Yep.
Right? So if I go down 5 pounds, I'm gonna bleed off 5 more pounds. If I go down 10 pounds, I'm gonna bleed off 10 more pounds. Right? I know recently we've been dealing with some racks that have got some pretty significant swing, 20, 30 pounds, right? Okay? If I go down 20 pounds, I'm gonna bleed off 20 pounds. That's what's gonna happen. Now, if this ball is closed and it's waiting its 20 to 30 minutes like we were talking about, that suction goes down 20 pounds, it's way too low, right? The rack knows that. It's gonna start turning compressors off to get that suction back up. Well, it's gonna overshoot that too, for all the reasons we talked about last week, right? So the pressure goes up, it goes past its target, it's 20 too low, goes past the target, spikes, right? We've seen all this on Tech Assist, we're seeing these big graphs. It spikes 20 over. It went up 40 pounds, right? I only had 20 to begin with. I'm 20 negative. I now have 20 pounds less than suction in my oil reservoir,
Yeah, feed.
right? Let's talk about the next place my oil's going. Keep that thought, right? So the oil's coming out of my oil reservoir and it's going to my float on that compressor, right? That float, as we talked about last week, the float bolts to the body of the compressor. Body of the compressor is near suction, right? Right? My oil reservoir is now 20 pounds lower than that. I don't have a high pressure to low pressure to flow. I'm going to flow 0 oil during that time. And it's gonna stay at 0 oil until my suction either pulls back down below that pressure that the reservoir was at, or this ball opens again and recharges discharge pressure so the OCV can reference the new suction pressure and give me a pressure again. During that time period, any compressor that needs oil, not getting it. It's not getting that oil. So that compressor could lock out on oil, right? If that compressor locks out on oil, my staging problem, you think that's gonna help it or make it worse?
Worse.
Yeah, right. Now my computer's asking for 2 compressors to run that aren't coming on. And its horsepower calculation is gonna be all wrong for each of those stages. And that swinging is gonna get even worse. Probably high, right? We're gonna spend a whole lot more time high. Every once in a while, we're gonna get spikes down, right? It's gonna be bad, okay? So while that's happening, every time this ball opens, I refill my 20 pounds in that reservoir, I'm gonna refill the floats of my locked out compressor. So when I show up as a service tech on this lockout, in this scenario, I touch my pipe. It's lukewarm, medium warm, right? It's got some heat, but not too much. Ball's flowing perfect, right? Go to my reservoir feels good, it's floating one ball. Great. Go to my sight glass on my compressor, 50%. Right, now I'm checking oil pressure, I'm doing all these diagnostics on this compressor. What's wrong with this compressor? It has plenty of oil. Nothing, there's nothing wrong with the compressor. Suction. Suction was what did it, right? Easily happen, okay? Easily happen. So it's really important we keep that suction nice and stable on a low pressure oil system particularly, okay? And this system is called low pressure oil, right? We call it low pressure because my oil reservoir is lower than discharge. That's why we call it a low pressure oil system. That's what that means, that OCV valve, right? And you say, anytime we see low pressure oil, we're talking about something like an OCV being involved that is referencing a lower pressure and lowering the pressure in that separator to a fixed amount over that, right? Yes, sir.
Just taking a quick step back, talking about filling up the reservoir all the way to the top, would you see any change in discharge temperature when you get to that third ball? Would it
Changing discharge.
Yeah, like would it
Unless your discharge
increase?
line's full of oil.
Right, that's right.
Okay.
Yeah, once you do that, you're gonna stop separating. You don't have anywhere to push that oil, so you lose your differential.
Yeah.
Okay, all that's gone. Your ball opens and
Nothing happens.
nothing happens, very little, right?
Yeah.
So now I'm gonna start filling this guy up. Right, so now I've got two oil separators, or reservoirs. Right, my oil separator, and my ball sits here. That can hold a gallon, huh? Maybe two?
Yeah.
Gallon and a half?
Yeah.
Till I get all the way up here?
Yeah.
Right. Well, one of the things that's gonna happen is, as I start losing the amount of space in here, because my oil's filling up, this guy's velocity is gonna change. It's not gonna be as good, right? So I've got less surface area to separate, so he's actually gonna stop separating. That's what we're gonna actually see happen, okay? So I'm gonna start filling up with oil until I get to a magic spot where I just don't have enough surface area for that to happen. I just stop separating.
Yeah.
Right, Michael? Oh, so that's how not letting oil out causes an oil separator to stop separating.
Okay.
Right, now, my cartridge style coalescent is gonna be less affected by this, right? Because it's a damn efficient oil separator. So at 98%, when I got the whole thing, now I start packing that thing full of oil. See how giant that is too. I put 2 gallons in there, yeah, maybe it's only 70% efficient, right? Still pretty damn efficient, still separating oil. So I'm gonna put another gallon in, right? So if I've got one of these big boys, and I think I've got a problem, and it may have oil in it, I could have 3 or 4 gallons, and that's a big thing. Okay, this guy, probably about a gallon, be ready for that. You could have up to a gallon in here. Right, when I take these bolts loose and lower this to clean it, when I crack that loose, I could lose it up to a gallon coming out of the gasket, right? Now, normally I won't. Normally I'm only gonna lose enough to lift that ball. That's not much, right? Maybe a pint, maybe. Yeah, that's about right. But if there's a problem, I better be ready for it, right? That's why am I pulling this out?
Yep.
I suspect it stopped up, right? Or something's not feeding and I'm checking it. I'm gonna have some oil. That's my low pressure oil system. Anybody got any questions about it before we move on?
So, and I've told myself this after somewhat proving it to myself. So the only difference between low pressure and quote unquote high pressure oil
We're gonna cover high pressure oil systems when I hit this next button.
is quite literally where it drops the pressure, right? at the point at which the pressure drops, your oil pressure going to the compressor should be
The same.
the same. If you have two identical racks and the only difference is one has high pressure, one has low pressure oil system,
You should
where,
have nearly the same oil pressure going your flow control. So, yeah, so let's talk about that for a minute while we're still on the low pressure oil system. So my OCV 20 guarantees oil's only moving by pressure, right? So I must have a pressure differential. My reservoir is at 20 pounds over suction. My oil control is bolted to my compressor. It is at suction. The most I'll ever have is 20 pounds, right? I'm probably gonna have less than that, okay? Now, if my rack is nice and stable, my suction is not going all over the place, all right? Why wouldn't I be 20 all the time? Well, I'm opening the float and feeding oil, right? That's gonna cause the pressure to go down. Guess what? That's about 17 pounds, roughly, is an average pressure that we would expect to find on a low pressure oil system with a textbook perfect suction, right? Which you're never gonna find. But that would be about 17 PSI, okay? That's why they choose the 20, okay? If I put too much oil on my oil, too much oil pressure on my oil control, right? I'm taking a liquid that's got refrigerant in it, and I'm forcing it through a little tiny hole with a low pressure on the other side. Our refrigerant's gonna do what refrigerant does. It's gonna refrigerate, right? When it changes state, changes into a vapor instantly, it's gonna expand. When it expands inside my oil is going to foam. That's what I'm gonna see. I'm gonna see not a little foam, I'm gonna see foam, like a lot of foam, all right? That happens somewhere above 30 pounds, right, on the oil control. I'm gonna go above 30 pounds, then when that oil float, when that ball lifts, I'm gonna see foam shoot into that sight glass on my compressor. That's what I'll see. When that happens, my foam doesn't have enough density to lift the ball, right? So I'm gonna keep feeding. I don't know how much oil I got. Until that foam settles down and becomes liquid again, I'm gonna feed that whole time. I can guarantee you I'm gonna overfill that compressor, right? That's one reason why if my pressure's too high there, that I'm gonna see all my sight glasses are gonna be way over halfway, right? The other problem I have is the ball, right? If we think about this, inside my flow control, which I didn't bring in today, we had it in here the other day. All right, my ball has to lift up against that same pressure that's pushing down on that oil. Once I've got it shooting through that little tiny hole, if it's at high pressure, it's harder to close. It's got to push against that pressure too, to actually get that pin to go up into the hole and seal, right? So once I cross about 30 pounds, I start having problems doing that too. So it'll open okay.
It won't close.
I can't get it to close very well, right? So I've got to get, this ball has got to be really submerged in oil and have lots of upward force to drive the pin all the way home and seal it off completely. I don't get close and then not quite seal. That's gonna fill my sight glass, right? So when my pressure gets too high, I'm always gonna run heavy on my oil in my compressor. Bye.
That's why they use the 20, they typically recommend the 20s to give you like a little buffer.
Yeah.
Exactly. All right, so why do I see 5s?
Because they're cheap.
because they haven't been changed to a 20.
Rip them out, put a 20 in.
There's a reason, There's one rack manufacturer who actually supplied 5s for a short period of time.
Go Phoenix.
And you guys know this, probably, right as it clicked, I'm probably about to put a piece together for you. But every time you walk into a Kaiser rack that has a non-adjustable oil float,
Yep.
it came with a 5 PSI OCV. Why? Well, you remember I told you last week, my big body Carlisles run 3/8 sight glass, not 50%. Well, if I put a fixed sight, I put a non-adjustable oil control on it that maintains at 50% all the time, that's too much. So how did Kaiser fix it? By starving it with oil, so it ran lower than half. They put the 5 on there, so sometimes I had 0, sometimes I had up to 5, that was the most.
That's crazy.
This seems like a really bad idea, right?
Yeah.
So basically they.
Right? So if we did that today with that 98% oil separator, this would be a disaster, it would not work, right? But back in those days, we didn't even have those. All right, we use the old coalescent bag style system. That bag style system, refrigerant comes in the top, into 2 bags of screen, that's all it is, right? At its very best, with perfectly clean screens, was around 30% efficient. So 70% of my oil was going through my store. So Kaiser's thought was, most of my oil is gonna go through the store, and I'm gonna use this oil system to just feed that 1 or 2 compressors that need more oil than the rest are getting. That was their plan, right?
Sounds good on me.
It didn't work. Ultimately it did not work, right? So every one of those are replaced with 20s today, okay? So just know that when you see a 5, if someone is trying to disguise a problem, right? Their problem is simply all their compressors are overfilling with oil. So they're putting a 5 on there so the oil system can't feed as much oil to the compressors. Because it's gonna be a 0 quite a bit.
See if I cuss the engineer, change it to a 20 and fix the oil problem.
So, and what's my oil problem? If someone is doing that, somebody's put a 5 on there, so they stop overfilling all their compressors, you're still gonna see some too full, right? But for the most part, it'll limp along for a while, right? What am I looking for? If I see a 5, technician swapped out a 20, he's put a 5 there, and I got a few glasses that are too full, which oil system is my problem?
Passive.
I'm relying on my passive oil system, and it's pulling back way too much oil, and it's not balancing, right? One of my suction pickup tubes is a little lower in the header for one compressor. That was the one that's filling up, right? That's what's gonna be going on, which means my passive oil system, I'm using it 100%.
Yeah.
My regular oil system's not working, right? I got a problem over here. I'm not feeding any oil through my active oil system. That's a dead giveaway that that's what's going on, right? The other thing I might do is I might walk in and find a 30. Why do I need, what's that telling me as a technician? Somebody swapped a 20 and they put a 30 on there. I need more oil pressure. 20 PSI was not enough oil to fill, that's, right?
We checked the rack legend first.
All right, so my oil control, we know it only needs a couple pounds, right? It needs 5 pounds maybe, all right? But if somebody put a 30 on there, right? I got 4 racks at this store, I got 3 20s, and I got 1 30, and this is the one that's got problems, right? What's going on?
They're trying
to feed more.
Go ahead.
Suction pressure's rising and dropping too much? It's not staying constant?
All right, so expand that thought. What's not constant?
Suction pressure?
All right, my suction pressure's moving too much. It's not that I need more oil pressure at my control, it's that my reservoir is falling with my suction too far. And then when the suction comes back up, I don't have any oil. So I'm trying to get another 10 pounds to help that. I got staging problems, that's what I've got. He just nailed it. If I walk in and I find that, I can tell you what I'm doing as a tech. First thing, do I have any compressors turned off? Toggle switch is off, right? So my staging's all screwed up. Step 1, step 2, how many circuits are cycling? How many circuits is it okay to have cycling on a rack? When I say cycling, I mean hitting the cutout and turning off for temperature and then coming back on.
Well, are you saying what is recommended or how much is okay?
Right. How many can I get away with?
As much as
25%.
Is
2 and deep.
no, you can. It's going to depend on what the loads of those cases are and what you can get away with without cycling off compressors.
So he just nailed it. There's no pat answer. There's no, this number is okay, right? There just isn't, right? Because of the load that I've got going on and all the variables that play into it. I don't know. I'll tell you that. I don't know the answer. I have seen one that was cycling really, really badly cause this problem, right? I've also walked into stores and found 4 or 5 that were cycling and the rack didn't have any oil problems, right? Really couldn't explain why. You'd expect it would, okay? So what's going on there and how many can you get away with? I don't know the answer to that. I can tell you that it's dangerous to have any. So you want to have 0. That's the goal.
Yeah, mechanical cycling bag.
If you've got massive oil problems and you got one little tiny cake case that's cycling, it's got 1 4-foot evaporator in it, that's probably not it, guys. You know, yeah, should you dial it in? Yeah, go ahead and dial it in, but yeah, that's probably not gonna save it, all right? Meanwhile, you walk in, you got 1 compressor turned off and you got 6 circuits cycling, oh yeah, there's your problem,
Yep.
Yeah.
right? Okay, yeah, nailed it, very nice, okay. All right, somebody mentioned something about high-pressure oil systems.
Who's that?
Okay, and I had Ian carry that in here last week and we didn't even use it.
That's my greatest weakness.
My high-pressure oil reservoir separator. You don't have to get it. I probably have a picture, actually.
Need a straw?
No, I don't. Is that, oh, yeah, I do. I got a picture of one. All right, so what's different about this, right? This is that magic voodoo high-speed stuff, right? It's really, no, it's super common, it's super simple if we understand low pressure, right? If you don't understand low pressure, this can be a little confusing, right? But all we're doing here is, if you notice my oil separator on my drawing, wait, let me use my little red highlighter here. My oil separator / reservoir, it's one piece. Okay? I don't have 2 separate pieces. We call it high pressure because my oil reservoir, that oil is resting at discharge pressure. I'm not bleeding, the OCV's not doing anything, right? There is no OCV. I'm not bleeding that pressure down. So that one vessel is one entire vessel that separates and stores. It literally is this, and I just put another gallon underneath it so it can hold the oil. Right? Literally the exact same separator. There is nothing different about the separator at all. I just gave it more capacity on the bottom and put some sight glasses in it.
Yep.
But notice I'm feeding the top and I'm going out the side. Hey, look kind of similar. It's literally the exact same separator, right? Doing the exact same work. I just welded a little more steel here so it can hold more oil, right? And I put my sight glasses under it. So, because that's where I'm holding the oil. That's all there is to it, okay? Now, so the separator reservoir, piece of cake. Now, I can have all 3 versions, right? I can have my filter, that filter setup, the coalescent, the temperite, right? I can use that, 98% efficient on a high-pressure oil system. Oh yeah, sure, absolutely can. Can I do it, can I use this helical? This is the most common.
Yeah, I was gonna say, I don't think I've ever seen a coalescent, not
Yeah.
yet anyway.
The bags, yeah, you can get them, you know, they're 30% efficient. Why? I don't know, it's old technology. But they make them, you know, you can absolutely have them.
Standard, but I've never seen
Alright,
a high-pressure.
So the separation, I still want to identify that as a technician, which system do I have, right? And this is the most obvious. I've got pipe in the top, pipe in the side, right? My refrigerant's flowing in and then out through the top. Anytime I see that, I've got this going on, regardless of the model, make, manufacturer. Henry does it different than this. They've got a screw inside here, but they're still causing your oil to spin.
Yeah.
Slide.
Centrifugal force.
Right, call it helical because it's screw, right? So when I walk up, that's what I want to see, right? If I see a giant steel plate with a gazillion bolts in the top,
Coalescing.
got a filter in there, right? Got a cartridge.
With the pressure.
Okay. So if I got 2 pipes coming in the top, that's gonna be my 2 bags, right? That's the old school stuff. Okay, so no difference here whatsoever. Now, the bottom does have a difference. If we look at our little drawing here, there's something we don't have. No float.
Yep.
Okay? I don't have a float. All right. This is an important difference in construction. This little tiny hole is, quote, the Achilles heel of this system. If I get a bunch of crap in here, and I will, right? This is where all the crap is gonna go, right? If I get a little bit of that crap in that little hole, I can either cause that pin to stay open or cause it to never to be plugged and never feed, right? That's our most common problem with the low pressure oil system, right here, this hole.
Or the ball gets a crack in it and then it fills up with oil and can't float.
And that can happen, sure, right? I got no float on this guy. I have eliminated all those problems. There isn't one. Cool.
Oh, yeah, valve though.
Now, if I get something large in there like a reed, right? Think about this, if I lose a discharge reed on a compressor, where's it going? Through the hot gas line and into my oil separator, that's where it's gonna go. And this guy, all right, it's gonna be laying right here,
If you're lucky, it falls to the bottom of the compressor.
if you're lucky. Yeah, you're probably not, it's probably going here.
Those
Most likely.
refrigeration guys.
Have you ever-
It's probably not gonna make it through that piston without that. Anyway, so on my high pressure oil system, that reed is gonna fall into and sink to the bottom of my oil reservoir, right? When the oil reservoir is feeding oil out, its little tube, little pipe, I got flow out. I could pick that reed up,
Yep.
seal that guy off, right? That happens, okay? I cannot take it apart and get it out. I can't, it's not serviceable. It's all welded together, it's all one piece.
You can't backflow either.
There is no way to get the reed out of that separator,
You're gonna have to change the whole separator to that reed piece. Wow.
right? That sucks,
That
okay?
sucks.
That has a little bitty hole in it?
So it's got this, yeah, 3/8 service line
Okay,
coming out,
yeah.
right?
Yeah, you're saying if it
Yep.
gets inside that valve.
And usually you can change that valve.
It's welded to the
You
bottom.
can unscrew the valve, but if it's stopped up on the inside.
Oh, yeah, no, yeah.
Now, here's the other thing, diagnosing this is difficult, all right? Because if I take pressure off of this system to check it, and the pressure's what's holding it there,
It's just gonna do, yeah, you're gonna buy yourself some time and that's gonna do it.
that's it, it's gonna work. I'm gonna put it all back together, everything works. Yay! I'll see you in 3 days.
Who knows?
So that guy picks back up and sits back.
All right, so we're not gonna diagnose that in one shot. I'm not gonna be the first guy to show up on this job ever and diagnose that I got a reed sucking into this thing. All right, we're gonna have to deduce that because it's happened, it didn't feed, we took pressure off, we stopped our flow, it cleared and then started flowing again.
Yeah, it's just bouncing around the bottom.
Right, now to confirm it, that's my now I got the thesis, I'm stopped up. Then to confirm that, I gotta see that happen a few times, right? Because I'm changing a separator. I mean, it's not a, 2 AM, I'll open Johnstone and grab one.
And that, you're taking the rack down for multiple hours.
Right, right.
Just a quick, thing, are those sight glasses welded or are they removable? And if they're removable,
They're
would you
Just
be
stick
able
a
to
magnet down in there.
fish a magnet down in that?
So unfortunately, most of my reeds are not magnetic.
Oh, the
They're
aluminum
stainless.
or stainless?
So it fits
Oh,
back
okay.
in there, I think.
Some of those are, some of them are not,
Yeah.
depends on the manufacturer, right? All these pictures that I have are Westmeyer's, by the way. I'm not in love with Westmeyer's, they just provide really good pictures. I can make some recommendations if you're thinking about who to go back with, other than Westmeyer. All right, so nonetheless, we've got another problem, okay? So we've worked through this. We've got our reservoir with all of our oil sitting with no ball, right? So no restriction in flow, okay, at discharge pressure. Now, we've already discussed our oil controls cannot take discharge pressure, right? So I've got to reduce that pressure somehow. I must reduce that. I gotta do the job of the OCV, right? I gotta get my oil pressure back down into the 20 PSI and lower range, okay? So the way I'm gonna do that is this Y1236 valve, all right? You can see that in my drawing here. You're gonna see my oil come out. It's gonna go through a filter, right? And then it's gonna go through this Y1236 valve. Now, this we can think of as an oil regulator valve. It is an adjustable valve that we can say, I want X PSI over my suction, and it will give me that. Here's how it works. The top of the valve has got a pipe that comes off of it that goes to my common suction header.
That's a
Sound familiar?
Yeah.
Well, that means the pressure that I'm setting on my 1, 2, 3, 6 valve isn't really a pressure, it is a difference
Yeah.
between wherever this pipe goes and the outlet of the valve. Okay? That's what I'm actually dialing in. That's an incredibly powerful piece. That means just like on my compound cooling rack, I'm using the OCV valve is referencing my interstage, right? That means I can make this reference my interstage, and it will give me that same 20 pounds if I want it,
Or you can do a little more.
or a little less, right? I can dial in exactly what I want, all right? Wherever that pipe goes. Now, where do they come? They come out of the box at 17 pounds, right? Does that sound familiar? Does that number sound, ringing any bells? Right? That's about where you want it. There's really no reason to move it. One of the advantages of this system is that crazy suction swing that we were talking about, right? If that happens on this rack, okay, my pressure coming out of here,
It's gonna just.
because I'm referencing this,
It will maintain.
it's gonna swing with it,
Yeah.
okay? As screwed up as that is, yeah, you know, I'd be sitting with my gauge on my oil control, watching that pressure go from 30 to 50, 30 to 50. Yeah, it'll do it, right? It's weird as shit,
That is.
okay? So, and when my compressor's running, it's also swinging. Yeah, there's a delay there, but it's not very long. I'm not gonna run out of oil with this system because of that massive side. Right? So it's an improvement there. The other place that it's an improvement, if I've got a satellite, let's think about that for a minute. If one of my suction groups is running low temp, and I got another set, remember we talked about this last week, if I got 3 compressors running low temp and 3 running medium, they have different suctions, but they have the same header for discharge, liquid, subcooling, everything else. Same oil system, right? We talked about this with the OCV. This is a real freaking problem. I've got to reference the higher pressure on the rack, and now I've got too much oil pressure on my low. I'm foaming, right? Okay, if I use this system, I can drop in 2 Y1236 valves, put a little T in here, and run up and put another Y1236 here, and its little pipe goes to the suction for my second suction group.
Why would we want a low pressure oil system over a high pressure oil system?
Yeah,
It
what-
seems like a high pressure oil system.
What are your advantages,
Yeah.
right? So the biggest advantage is serviceability. That's what I just talked about. When this one goes south,
It's done.
you're changing an oil separator, and like I said, you're not doing that at 2 o'clock in the morning.
Right. You're
Right?
losing drop.
If you've got a low pressure oil system, can you drop that flow at 2 o'clock in the morning? Oh, yeah.
Yeah. Clean it, get it back together.
Yeah, and then like you're saying, if that reed, and if you get a reed or whatever stuck in that valve, like,
Yeah, you're all-
you are gonna have to manually pump oil to those compressors to keep that.
Pretty much. You've done that.
If you are married to that rack now, until.
All right, so does that eliminate the mysteries on high pressure oil system? So the next thing, after we come out of our oil separator, remember, we're tracing out a refrigeration cycle, right? And when we come out of our oil separator, the next thing we're gonna hit is, on a parallel rack system, is a check valve. Yep. Okay? Now, this is one of those things that's kind of out of sight, out of mind. We hardly ever have any issues with it. But let me talk about what it is, why it's there, and when we're gonna have problems. Okay, the purpose of the check valve is to allow refrigerant, you can see my arrow pointing, that is the flow direction that is going to, that refrigerant is traveling up towards my condenser. Well, generally, our condenser is at the same height as my rack or higher, right? We generally prefer them to be higher. So the refrigerant flows through my condenser, and it condenses, obviously, into a liquid in my condenser, which is weight. Heavy weight, and as long as my compression cycle's still working, I'm always going to flow from high pressure to low pressure, so that weight is going to fall out of my, what we call drop leg, and move towards my cases, right? Because that's where the low pressure is on the other side of that compressor. My challenge is my refrigeration cycle is not functioning, i.e. my compressors aren't running. If I don't have a single compressor running, I no longer have a pressure differential, but I have a lot of weight overhead in my condenser.
Low load, low ink.
All right, that weight, that liquid refrigerant is gonna fall down both pipes. Right, it's going to fall down my hot gas discharge towards my oil separator. Just naturally will, right? If I fill that liquid separator, my oil separator with liquid refrigerant, we know what happens, we've seen this a few days ago. I'm gonna feed it to my compressors.
They're not gonna like that.
It's not gonna like it, right? When I start shooting that liquid refrigerant into my journals and my bearings, it's gonna boil off, right? I'm gonna get metal on metal. I'm gonna destroy things, right? So I'm gonna put that check valve in there so that that liquid cannot fall that far, right? I'm gonna stop it from hitting my separator, right? Now, if I get my system running again, and I create my low pressure and my high pressure zones, and my refrigerant flow is gonna be proper, and that entire thing is full of liquid, it's not gonna be a problem. Not really. I'm gonna have a lower pressure on the other side now, and I'm gonna boil it off,
Yeah.
right? It's just gonna boil off. And then my hot gas will heat it up and speed that process up until it clears right out. It'll clear out very quickly, okay?
Yeah.
But that's what that check valve is for, right? That's its purpose, is when my rack is off, to prevent the liquid from falling out of my condenser and going into my separator, right? So when am I gonna have a problem? Well, if that check valve is a restriction, I'll be running high discharge pressure right up until it, but then not after it. Pressure differential, okay? How would that present? The way that we'd see that, I've got compressors locking out, but my discharge of my rack is not too high, right? I'm tripping compressors and I'm sitting there at 250 on the discharge. What's going on? Screw my gauge on in my compressor. Sure enough, it's hitting 375. I got a restriction somewhere. That check valve could be it. The next thing I want to talk about in the discharge line, after I've left my check valve, if I have one, and not every rack has one, the next place that I'm going to hit, the next thing I'm going to hit is going to be heat reclaim. All right? So heat reclaim can be a number of different things. One of the most common is water. We're gonna take water, we're gonna run refrigerant waste heat before we go to our condenser through it, and we're gonna make hot water, right? Supply the store. Another very common place to use this is reactivation or reheat on a dehumidification system, right? I'm using my compressors to cool that air, so I'm shrinking the envelope, shrinking my bucket, so I've got less water in it, and then now my air is too cold, and I need to heat it back up, right? Well, instead of running electric heat, I've got waste heat that I'm getting ready to try to use fan motors to reject. Perfect place to do that. It can be a number of things, right? Doesn't matter. Now, the way that we're gonna do that is through a three-way valve, okay? Three-way valves have really two major differences in their configuration. It's important that we understand which is which. They're not interchangeable. So we'll talk about that for just a second. In this case, that's what it's gonna look like. That's the hot gas pipe coming straight off my, oh wait, I have a red dot. Coming off my separator, coming right out of my check valve, and it's feeding right there, okay? In this example, you know, these pipes are coming over here to my heat reclaim. So my computer, my rack controller, is gonna make the determination on what's going on here, if I can energize this or not. What would cause me to not low refrigerant level, right? If my rack knows that it's running out of refrigerant, it's not going to, quote, waste some on heat reclaim, okay? So that's just one of those things to keep in your mind. Why is my heat reclaim not working? Could be low refrigerant. That's one of the requirements for using heat reclaim is my rack's got to say it's okay, all right? The other thing it's monitoring, of course, is either hot gas or discharge pressure. If either of those falls too far, I don't want to reject more heat. Right, it's going to be a bigger problem, okay? Now, the other thing that we may be using to make this work is a mechanical temperature sensor, right? Seen that too. Strapped right to the water pipe going to the store. They use recirculated water, right? When that water gets cold, that thermometer closes its contact. Okay, well, how can I have a computer and a mechanical device? They're just wired in series, right? They all have to be closed to energize the solenoid on the three-way valve. Okay, pretty simple. And the keys here, the really important part that I want you guys to to take away from this three-way valve, and you see the picture of it, right? You see what it looks like, and now I've got a drawing here. What I want to point out is this is the piece that moves, that changes my flow inside this valve, right? We can see that it's seated and plugging this hole, right? If my refrigerant comes in here and flows out here, I'm reclaiming, right? This is blocking the hole, right? So instead, I'm coming out and I'm going out here. Now, if I actuate this and I move this piece to here, I block this part and it forces my refrigerant through the other side, right? This particular three-way valve is made to be this one or this one, but not both. Okay? This one or this one. I have to make a decision. Which do I want to use? I cannot use both. Right? We're going to use that version of our our three-way valve for heat reclaim. Okay? My condenser is what's going to be piped down here. Right? So if that valve is closed, I'm not sending my refrigerant to my condenser, I'm sending it to my water tanks. Then I'll use plumbing to then take it from my water tanks to my condenser. But this valve is going to say, no, go to water tanks. Right? If I flip-flop it and it's in this position, it's going to say no hot gas goes to my water tanks at all. It's all going straight to my condenser. Right? One or the other, but not both. All right. Oh, I know where I get into the rest, the other type of valves coming up. We're going to get into 50% splits. All right, so that's the end of our class from last week.
Halfway through this week's class.
All right. Anything we want to talk about? Now, this is compression and the first half of my condenser. Anything you guys want to talk about that we've already covered before we move on? This is actually, kind of a nice place to break this up. This is on our refrigeration cycle. Remember, we've covered our compressor, a little bit of the suction leading into the compressor, and a little bit of the discharge pipe coming out of the compressor. That's it, right? So we got a lot more we got a lot farther to go.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.